Hi everyone! Welcome back to integralcalc.com. Today we're going to be doing a long division problem with polynomials. It's just like the long division that we all learned in elementary school, but it's with polynomials. So this fraction is x cubed minus 1 divided by x plus 2. And the way we set this up is we put the denominator on the outside and the numerator on the inside, which is always the case. So we set it up like this, and actually let's go ahead and do this. The reason that this particular problem is interesting is because, let me rewrite this a little bit, is because the degree of the numerator is x cubed, right? It's a third degree polynomial because the first or the highest exponent is cubic. It's the x to the third. But we are missing the x squared term and the x term. We go straight from the third degree term all the way down to the constant. So what we're going to want to do is leave a blank space for the squared term, a blank space for the x term, and then we'll go ahead and write our constant term here. And the reason that we're going to do that, you'll see in a second why that's important. So whatever you've got inside this long division bracket here, whatever's in your numerator, you should leave gaps like this if you're missing terms to any degree. We're missing, again, the x squared term and the x term. So now what we want to do is figure out what we have to multiply by x in order to get x cubed. Well, of course, that's x squared, right? If we multiply x squared by x, we'll get x cubed. So we write x squared up top here, and then we go ahead and multiply x squared by every term in the polynomial on the outside, x plus 2. So x squared times x gives us x cubed, and then x squared times 2 gives us plus 2x squared. So once we've multiplied through, we can go ahead and put parentheses around this. I think it makes it easier to see sometimes. And then we subtract, and we're always subtracting. So we get x cubed minus x cubed, which is 0, and that's the point of making sure that this term here multiplied by the term out in front gives us the first term inside the long division bracket, because we're trying to get things to cancel. So x cubed minus x cubed gives us 0. This becomes a negative 2x squared, because basically we've got 0 and then the minus. Positive 2x squared is a 0 minus 2x squared, so that's just negative 2x squared. So we've got that. Normally we would bring down the term that's right here. We would carry that down, but there's nothing there, so we won't bother with it. Now we have to figure out what to multiply by x in order to get negative 2x squared. Well, of course, that is negative 2x, right? So when we now multiply negative 2x through this polynomial out here, we'll get a negative 2x squared minus 4x. And again, once we've multiplied through, we'll draw our parentheses and subtract. Now we've got a negative 2x squared minus a negative 2x squared. Because we've got the double negative here, this becomes a positive. So we get negative 2x squared plus 2x squared, which of course gives us 0, which is what we want. We've also got a double negative on the 4x here, so we get basically 0 plus 4x. We end up with a positive 4x. Now we carry down the next term, which is a negative 1. That comes down here, so we get negative 1. And now we want to figure out what to multiply by x in order to get positive 4x. Of course, that's just 4. So now we multiply 4 all the way through this x plus 2 here, and when we do that, we get 4x plus 8. So getting 4x plus 8, we'll draw our parentheses and subtract. 4x minus 4x gives us a 0, that cancels, and then we get negative 1 minus 8 gives us a negative 9, right? And now we can't go any further. There's no other term out here to bring down, so we know we're certainly done with that part. If we wanted to figure out what to multiply by x to get negative 9, it would of course be negative 9 divided by x. That starts getting messy whenever we have to multiply by a fraction in order to get this. We want to stop and call what we got here the remainder. So to write our final answer, we take everything up top here. So that'll be x squared minus 2x plus 4. And then we add to that the remainder. And the remainder here is this part, right? Whatever we got down here, which was a negative 9. So we'll go ahead and say minus 9. And we divide that by what's out in front. In this case, x plus 2, which is our original denominator, the denominator in our original problem, right? So the remainder was negative 9. So we go ahead and say minus 9 divided by x plus 2. And that's our final answer. So I really hope that video helped you guys, and I will see you in the next one.